Hello and welcome to this A-level enthalpy profile diagram question. There's a couple of things in it that you need to watch out for that make it slightly more applied than normal. So it gives you a reaction between hydrogen and carbon dioxide to make methanol and water, and it says in the reaction that 49 kilojoules of energy are released. In other words, it's an exothermic change when 3 moles of hydrogen react completely. So the first thing to do is to work out how much energy is released when 1 mole of hydrogen is reacted in this way. So that's 16.3 kilojoules per mole. Notice I'm keeping my calculator value, so I don't round until the very end, even though it says give your answer to 3 significant figures. The next thing we do is calculate the energy released when 1,000 decimeter cubed of hydrogen measured at room temperature and pressure react completely with carbon dioxide. So this is V equals 24N because it tells us that it's measured at room temperature and pressure, so that's a clue to use the V equals 24N formula rather than PV equals nRT. So rearranging it so that the number of moles is the subject, that means the number of moles of hydrogen must be 1,000 over 24, which is 41.666 recurring. Again, keep the calculator value, don't round it just yet. So for this particular number of moles of hydrogen, you multiply that 41.666 recurring times 16.3 calculator value, and it gives you 680.555. Now, if you look at what it says, it asks you to give the answer to 3 sig figs. This is where you do your rounding. So this brings us to 681. So the next part of the question gives us an enthalpy profile diagram that's not fully completed. So the first thing to do is to draw the obvious parts out and then put in your activation energy and your delta H. So the arrows should start at the reactant level, and they should point directly at the highest part of the curve for the EA value and at the level of the reactants for the delta RH value. So remembering what it said earlier, in this reaction 49 kilojoules of energy are released when 3 moles of hydrogen react completely, and that we'd worked out that the energy released must be 16.3 kilojoules per mole for every 1 mole of hydrogen. So for the reverse reaction, there's 2 things to consider. It's endothermic and it's for 3 moles of H2. So just taking a laser pointer so we can think about this. We're going from here to here now, not the other way around. So this is the reverse reaction we're talking about. So to work that out, you need to multiply 3 times 16.33 recurring that we worked out before, which gives us 48.99 recurring, which gives us 49 kilojoules per mole as our enthalpy change. So remembering that endothermic enthalpy values must always be positive, I'm just going to be on the safe side and put a plus sign in front of my 49.0. Okay, thanks for listening. Until next time, see you soon.